Okay, this is section 4.4, the slope of a line. So first, what do you think of when you hear the word slope? I think of, let's see, maybe slant, uphill, downhill, rise over run. Let's see, the variable for slope is m. Those are some of the things that I think of. Okay, now let's suppose we had a ladder leaning against a wall. Depending on how far away it is from the base, what happens to the slant or slope? Well, this one is further away from the base than this one. So this one right here has a greater slope. This one is much further away from the base, so it has less slope. Okay, now slope can either be positive or negative. I like to remember it as if it's positive, it's like a check mark and the line will follow the long edge of the check mark, and that's positive. Negative, that means no. So this one for this sign for like no smoking, do not enter, and those lines always fall downward going left to right. I expect you to be able to look at a line and determine whether the slope is positive or negative. Now the slope, like I said, the variable used is m, and slope is a rate of change. It's going to be your change in y divided by your change in x, or it could be delta y over delta x. That means the same thing, or some people like to refer to it as rise over run. Okay, we have two ways that we can find the slope. We can just use the graph, or if we're given 2 points, we can find it algebraically. So first we're going to use a graph to find the slope. So I've got my 2 points are marked with a dot. Now when I give you something like this and I want you to use the graph to find the slope, the line will cross at precise intersections. It won't be anything where you've got to guess what it is. It will cross right where those two lines meet. So now I'm going to see, I've got my first point marked. I'm going to see how much I need to rise. So I'm going to rise 1, 2, 3, and then I'm going to run 2. So it's rise over run. I can look at this line and I know that it is a positive slope, so then I know that my slope is 3 over 2. Now let's take a look at this one. Again, my points are marked with a dot, and notice they are at precise intersections. You may have to look a little bit to find it, but I promise whenever I give you one of these problems that it will always be there. So let's see how much we rise. Well, first, what kind of slope do I have? I have a negative slope. So I know that slope is going to equal negative something. Now let's see what my rise is. See, I rise 1, 2, 3. Now let's see how far I run. Let's see, 1, 2, 3, 4. I'm going to run 4. So my slope is negative 3/4. Now sometimes we're going to need to find our slope algebraically. Now when I find my slope algebraically, I'm always going to use the formula m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now it doesn't matter which set of points I label what, so that's just going to all be personal preference. So I'm just going to label this x1, y1. I'm going to label this one x2, y2. I'm going to make sure that I keep these guys in order. So now I have slope is equal to, let's see, y sub 2, that's 2, minus 4. X sub 2 is negative 2. X sub 1 is 3, so negative 2 minus 3. I can look at this. I know that my slope is going to be positive, so when I finish, I'd better have a positive answer. What's 2 minus 4? Okay, that's negative 2. Negative 2 minus 3. Signs are the same. Add and keep the sign. We're negative 5. Am I finished? No, I need to simplify. Negative over a negative is a positive. Remember, two wrongs don't make a right, but two negatives make a positive. So my slope is positive 2/5. My slope that I calculated is positive. When I look at this line, I can see that it is positive. So I'm pretty confident with my answer. Now let's do this one. Find the slope of the line that passes through the points 0, 0, and 3, negative 3. Again, I'm going to label these. I can label these any way that I want. I can go x1, y1, x2, y2. I just have to remember to do it xy, xy. Doesn't matter which one I make as point 1 or point 2. I just have to be consistent. So now I have slope is equal to negative 3 minus 0, positive 3 minus 0. So that gives me negative 3 over 3. Oh, I can simplify that down to negative 1. So I've calculated my slope to be negative 1. Now I'm going to look at this. Negative. Oh, this slope is negative also. It's similar to that of a no smoking or do not enter sign. So I'm confident with my answer once again. It's a great way to check for mistakes. You know, we do have some special cases. A horizontal line is one. So let's double check these points. Okay, so x1, y1, x2, y2. So I know that my slope is equal to 4 minus 4 over 3 minus negative 2. Oh, what's 4 minus 4? 0. 3 minus negative 2 turns into 3 plus 2, so that gives me 0 over 5. And what is 0 divided by 5? 0. So all horizontal lines will always have a slope of 0. Okay, your second special case is a vertical line. So again, let's take a look. I'm just going to do x1, y1, x2, y2, just to make sure I put everything where it goes. Slope is equal to 1 minus 4 over 3 minus 3. 1 minus 4 gives me negative 3 over 0. And what is negative 3 divided by 0? Don't just say 0. Plug that in your calculator if you're not sure. When you plug that into your calculator is going to give you an error message. So the slope is undefined. So all vertical lines have an undefined slope. Okay, let's do a quick recap. If the line rises, the slope is positive. If the line falls, the slope is negative. Horizontal line always has a slope of 0. And a vertical line has a slope that is undefined. Okay, now we're going to be given the slope, and they want us to find a coordinate point. What equation have we already worked with that has the slope and two coordinate points? All right, slope is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So we're just going to plug the values that we know into this equation and solve for the variable that we need. Okay, so now we have find the value of y so that the line passing through the points negative 2, 1 and 4y has a slope of 2/3. Well, I'm going to start with my formula. Y is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. My slope is 2/3, so I'm going to plug that in for m, is equal to, let's see, I'm going to call this Let's call this x sub 1, y sub 1, x sub 2, y sub 2. Like I said, doesn't matter which one you do what. So y sub 2 is going to be y minus 1 over 4 minus negative 2. Be careful, make sure you include that negative from the x value. So now we have 2/3 is equal to y minus 1. 4 minus negative 2. Well, 2 wrongs don't make a right, but 2 negatives make a positive, so that turns into 4 plus 2. 4 plus 2 gives me 6. Well, I need to get rid of that denominator so I can start isolating my variable. So I'm going to multiply both sides by 6. Okay, this is going to simplify. 3 goes into 3 one time, 3 goes into 6 twice. 2 times 2 gives me 4 is equal to y minus 1. I'm going to add 1 to both sides. So I get 5 is equal to y. Now, one thing that's really good about slope is you can use it to interpret some pretty good information. So right now there's a parachuter at time t equals 0 seconds. So that's this point right here. You open your parachute and you're at a height of 2,500 feet above the ground. Then at 35 seconds, you're at a height of 2,115 feet above the ground. Well, what is your rate of change in the height? Okay, so they're really asking just what's the slope. And in this case, the slope is going to determine the rate that the parachuter is descending. Because I'm telling you, if it's really, really fast, there's no way I'm going to try that. So I want you to calculate the slope using the points that they gave us. And this time they gave us the points in a different way. So our points for this one are the points 0, 2,500. And then our second point is 35 and 2,115. Notice that time is what's along the horizontal axis, so that's going in the x location. The height is on the vertical axis, so it's going where we normally put y. So I'm interested to see what you come out with. Okay, so when you checked that, did you get that the rate of change was falling 11 feet per second? And then you could also use that information to calculate when you would reach the ground. They would reach the ground about 227 seconds after they jumped.